You think you know how science works. Data, hypothesis, test, repeat. But what happens when the data says your entire worldview is garbage? What happens when 8 minutes of arc, 1/8 of a degree, smaller than the width of a grain of sand held at arm's length, demands you abandon everything you believe? December 27th, 1571. Wilderstadt, a small town in the German province of Württemberg. A boy enters the world 2 months early, body already failing. Smallpox hits before he turns 6, hands scarred, vision wrecked. The kind of damage that ends any dream of becoming an observational astronomer. Johannes Kepler cannot see the stars clearly. He will spend his life making them make sense anyway. His mother Katharina runs a tavern, mixes herbal drinks, carries a reputation as sharp-tongued and difficult. The family is broke, the marriage is toxic, but the boy is brilliant. The Lutheran scholarship system in Württemberg spots him. Boarding schools, University of Tübingen by 1590. There, studying theology, he discovers Copernicus, the sun at the center. Earth just another planet. It clicks. This is true. This has to be true. Most people in 1590 still believe Earth sits motionless while everything else spins around it. Kepler bets his career on the opposite. The ratio between the inner circle and outer circle matches the ratio between Jupiter's orbit and Saturn's. What if the entire solar system is built on geometry? What if God used shapes? He tries two-dimensional polygons. Doesn't work, not enough planets. Then he pivots. 3 dimensions. The 5 Platonic solids: octahedron, icosahedron, dodecahedron, tetrahedron, cube. 5 gaps between 6 planets. Nest them between spheres representing planetary orbits. Mercury inside an octahedron. Venus outside it, inside an icosahedron. Earth outside that, inside a dodecahedron. Mars outside that, inside a tetrahedron. Jupiter outside that, inside a cube. Saturn bounding everything. He publishes Mysterium Cosmographicum in July 1596. The ratios match within 10%. 10% error seems small enough. He believes he has found the blueprint of creation. Institute of Nuclear Physics and detailed analysis from the University of Ohio's Astronomy Department lecture archives. These aren't generic references. These are the datasets and university archives that document Kepler's actual calculations and the 8-minute discrepancy that nearly broke him. Now back to the information. Built 2 massive observatories funded by the King of Denmark. 20 years of planetary observations. Accuracy down to 1 or 2 arc minutes. That is 30 times more precise than anyone before him. No telescope yet exists. Tycho uses gigantic quadrants and sextants, custom instruments as tall as buildings. He measures planetary positions night after night, recording everything. By 1600, Tycho has the best data set in the world. Kepler knows it. Tycho knows Kepler is brilliant. But Tycho also knows Kepler is Copernican, and Tycho has his own model, the Tychonic system. Earth at the center, Sun orbiting Earth, but all the other planets orbiting the Sun. A compromise. Tycho doesn't want Kepler proving heliocentrism with his data. Kepler gets assigned one problem: Mars, the most difficult orbit. Tycho probably hopes it will occupy Kepler long enough that Tycho can finish his own theory first. Kepler bets he can solve Mars in 8 days. October 24, 1601, Tycho Brahe dies suddenly. Kepler inherits the post of imperial mathematician to Emperor Rudolf II. More importantly, he inherits all of Tycho's observations. The war with Mars begins in earnest. Kepler starts with circles. Everyone uses circles. Aristotle said celestial bodies move in circles because circles are perfect. 2,000 years of philosophy demand circles. Even Copernicus, who moved the sun to the center, still insisted on circular orbits. Kepler tries circles with the sun slightly off-center. He tries adding an equant point, a geometric trick Ptolemy used where the planet moves at constant angular speed as seen from a point. That isn't the center. He adjusts the radius. He adjusts the offset of the sun. He adjusts the position of the equant. He calculates for months, years. They align. 4 points match perfectly. 5 points, 6 points. Then a 7th observation, 8 arc minutes off, 8 minutes of arc, 1/8 of a degree. To understand how small that is, hold a grain of sand at arm's length. That's roughly 8 arc minutes. At the distance of Mars, 8 arc minutes translates to about 500 miles of position error. Sounds large, but Mars is 140 million miles away at opposition. 500 miles out of 140 million is tiny, 0.0035%. Any other astronomer would call it measurement error and publish. 8 minutes is systematic, not random. Kepler writes later, "If I had believed we could ignore these 8 minutes, I would have patched up my hypothesis accordingly. But since it was not permissible to ignore them, those 8 minutes pointed the road to a complete reformation in astronomy." Move to the next planet. His career would be secure. Rudolf II would be pleased. But good enough isn't true. 8 minutes means something is fundamentally wrong with the circular assumption, not a minor correction, a structural failure. The data is screaming that reality does not work this way. Most scientists ignore screams like this. Too inconvenient, too disruptive. Kepler listens. Round them off. Call it measurement error. Move on. Publish, everyone else would. But he doesn't. He tears up the circular model. He starts from scratch. Mars must be moving in some non-circular path. But what shape? And how does speed vary? He needs a physical principle. He hypothesizes the sun emits a force like magnetism that pushes planets along their orbits. The force weakens with distance. This means planets should move faster when close to the sun, slower when far. But how much faster? How much slower? He needs a mathematical rule. The triangle formed between these two lines and the curved path segment has a certain area. Now pick any other point on the orbit. Repeat the process. 10 days of motion. New triangle. Different shape. But the same area. Always the same area for equal time intervals. This means when the planet is close to the sun and the radius is short, it must sweep out a wide angle to get the same area. When far from the sun with a long radius, it sweeps a narrow angle. Speed is inversely proportional to distance from the sun. The orbit bulges slightly outward on the sides. Maximum deviation is about 0.00429 times the radius of the equivalent circle. That's 0.429%, less than half of 1%, but consistent across all measurements. An oval is fatter at one end, but the Mars orbit is symmetrical. Same shape on both sides of the long axis, just shifted off center. He needs a symmetrical, flattened circle, not an asymmetrical egg. He doesn't know what to call this shape. He calls it an oval in his notes, but he knows it's not quite right. Every 687 days, Mars returns to the exact same position. The sun is fixed. Mars is fixed. That gives him a baseline. He triangulates Earth's position at different times by measuring angles to Mars and the sun. He discovers Earth's orbit is closer to circular than Mars, with the sun about 1.5 million miles from the center, radius 93 million miles. Eccentricity small but real. Now he attacks Mars with full force. He knows the orbit is not circular. He plots points. The shape is an oval. He measures the deviation from a circle. Maximum difference is 0.00429 times the radius, less than half of 1%. Tiny, but consistent. The oval is systematic, not random error. He tries various oval shapes, egg shapes, flattened circles. Nothing fits exactly. Then he works on optics, unrelated problem. People notice the moon appears different sizes when viewed directly versus when seen through a camera obscura. Kepler investigates. He figures out how lenses and curved surfaces bend light. He produces the first correct mathematical theory of the camera obscura, also the first accurate explanation of how the human eye works, upside-down image formed on the retina. These results get published in Ad Vitelionem Parallelopomena in 1604. While researching refraction, he studies conic sections, ancient Greek geometry from Apollonius of Perga around 240 BCE. The circle is a special case of the ellipse where both foci merge into a single center point. The ellipse is defined by two focal points. The sum of distances from any point on the ellipse to both foci is constant. That's the geometric definition. Algebraically, the ellipse has the equation x squared over a squared plus y squared over b squared equals 1, where a is the semi-major axis and b is the semi-minor axis. Kepler is studying this geometry for optical reasons, but his mind is always on Mars. What if Mars moves in an ellipse? He places the sun at one focus, the other focus is empty. He calculates what the orbit should look like. He plugs in his measured value for orbital eccentricity, about 0.093 for Mars. He computes where Mars should be at different times according to an elliptical orbit with the sun at one focus and motion governed by the area law. He checks against Tycho's observations. They match perfectly, every data point. No 8 arc-minute errors, no half% deviations. The ellipse fits exactly. Years of calculations, thousands of pages of trigonometry, 70 different orbital models, all wrong. Then the ellipse, one try, perfect fit. He measures the angle that Mars subtends at the baseline between the sun and the center of the orbit when Mars is at a certain position. 50 degrees, 18 arc minutes, 5.3 degrees. He calculates the secant of this angle, 1 divided by the cosine. The secant is 1.00429, the same ratio as the maximum deviation of the orbit from a circle. The secant of the angle equals the ratio of the sun, Mars' distance to the distance from the center of the circle to Mars. This is only true for an ellipse. The geometry locks together. Mars moves in an ellipse. The sun sits at one focus. Motion follows the area law. Everything fits. He is still working for Rudolf in Prague. Political tensions, religious conflicts, Protestant versus Catholic. The Holy Roman Empire is fracturing. Printing delays stretch for years. Meanwhile, in October 1604, a new star appears in the constellation Ophiuchus, supernova. Kepler observes it, writes about it. De Stella Nova, 1606. He rejects dozens of explanations for the new star. At one point, he notes it could be a special divine creation. But before we come to that, I think we should try everything else. Chapter 22. Try natural explanations first. Only invoke the supernatural as a last resort. These laws describe Mars. He infers they apply to all planets. He is correct. The title page says the book is based on observations of Tycho Brahe and explains the motions of the star Mars. Kepler doesn't call them laws yet. Nobody does. They are observations, regularities, patterns derived from data, but they are accurate. They predict positions better than any previous model, better than Ptolemy's epicycles, better than Copernicus's circles, better than Tycho's hybrid system. Ellipses work. The reformation of astronomy has begun. The universe is not random. The Platonic solids gave an approximate answer back in 1596, but Kepler wants precision. He wants the exact relationship. There has to be a mathematical harmony governing the whole system. Interval. Mercury's eccentricity is large, 0.206, perihelion at 0.31 AU, aphelion at 0.47 AU. Speed ratio is about 12 to 5. That's a minor tenth in music theory. The interval between C and E flat an octave higher. Venus has the most circular orbit. Eccentricity, 0.007, nearly circular. Speed barely varies. The interval is about 25 to 24, called a decis. The smallest interval a human ear can detect, less than a semitone. Mars has eccentricity, 0.093, speed ratio about 2 to 3. A musical fifth, due to Sol. Jupiter is 0.048, ratio about 5 to 6, a minor third. Saturn is 0.056, ratio also about 5 to 6, minor third. Mars at aphelion, Earth at perihelion. Each pair forms a musical interval, some converging, some diverging depending on whether you compare closest or farthest points. Most intervals are within a dices, 24 to 25, of a perfect consonance, perfect fifths, perfect fourths, major thirds, minor thirds, octaves. The solar system is a cosmic choir, each planet a voice. Mercury soprano, Venus and Earth altos, Mars tenor. Jupiter and Saturn basses. Most of Book 5 of Harmonicus Mundi explores these musical correspondences in exhaustive detail. Kepler believes he has discovered the harmony of creation, the music of the spheres, not as metaphor, but as literal mathematical fact. At very rare intervals, maybe only once in history, all planets might sing together in perfect concord. Perhaps at creation, perhaps never again, but the potential is there in the geometry. Then, after sending the manuscript to the printer in early 1619, Kepler tries one more calculation. He has been searching for years for a relationship between orbital period and distance. How long a planet takes to complete one orbit versus how far it is from the sun. He has tried linear relationships. Period proportional to distance. Doesn't work. He has tried period proportional to distance squared. Doesn't work. He has tried square root relationships. Doesn't work. May 8th, 1618. He tries period squared versus distance cubed. He squares the orbital period of each planet. Mercury, 88 days squared equals 7744. Venus, 224.7 days squared equals 50,491. Earth, 365.25 squared equals 133,408. Mars, 686. 0.98 squared equals 471,842. Jupiter, 4,332.8 squared equals 18.78 million. Saturn, 10,759 squared equals 115.8 million. Venus, 0.72 cubed equals 0.373. Earth, 1.00 cubed equals 1.00. Mars, 1.5, 2 cubed equals 3.51. Jupiter, 5.20 cubed equals 140.6. Saturn, 9.54 cubed equals 868. Take the ratio of period squared to distance cubed for each planet. Mercury, 7744, divided by 0.0592 equals 130,800. Venus, 50,000. 491 divided by 0.373 equals 135,400. Earth, 133,408 divided by 1.00 equals 133,408. Mars, 4, 71,842 divided by 3.51 equals 134,400. Jupiter, 18.78 million divided by 140.6 equals 133,600. Saturn, 115.8 million divided by 868 equals 133,500. The square of the period divided by the cube of the semi-major axis equals a constant. Kepler conceives the relationship on March 8, 1618. He tries calculating it one way, gets it wrong, rejects it. May 15th, he tries a different approach. It works. Stormed the darkness of his mind, he writes later. He has found the third law, the harmonic law, the relationship that connects all the planets, not just individual orbits. The entire system, one mathematical rule that every planet obeys. Period squared over distance cubed equals a constant. That constant turns out to be 4 pi squared divided by the gravitational parameter of the sun. But Kepler doesn't know that yet. He doesn't know about gravity, he just knows the numbers work. The third law appears in chapter 3, section 8. Not highlighted, not emphasized, just stated as another example of cosmic harmony. The real treasure buried in pages of polyhedral geometry and musical intervals. But it is the key. Newton will later prove this law derives from universal gravitation. For any two objects where one orbits the other, the period squared divided by the distance cubed equals 4 pi squared divided by g times the mass of the central object. G is the gravitational constant. For the sun, the mass is about 2 times 10 to the 30th kilograms. Plug in the numbers and you get Kepler's constant. The third law is a consequence of gravity, but Kepler discovers it without knowing gravity exists. Pure empiricism. Measure, calculate, find the pattern. Comment your city. This research is drawn from Johannes Kepler's own Astronomia Nova, published 1609, and Harmonices Mundi, published 1619, cross-referenced with modern analysis published by the American Astronomical Society in their February 2019 historical feature, marking the 400th anniversary of the third law's discovery. We are pulling directly from Kepler's documented calculations and the university archives that preserve his battle with Mars. Back to it. The relationship between how far a planet is from the sun and how long it takes to orbit. Newton will later prove this law follows directly from universal gravitation. Kepler doesn't know about gravity yet. He's working backward from observation to principle, but the principle is correct. Kepler notes this in his 1621 Epitome of Copernican Astronomy. Any object orbiting any central mass obeys the same mathematical relationship. The law is universal. 68 years later, Isaac Newton publishes Principia Mathematica. He shows that Kepler's 3 laws are consequences of his law of universal gravitation and laws of motion. Every object attracts every other object with a force proportional to their masses and inversely proportional to the square of distance between them. Kepler's laws become proof. Newton writes, "To the same natural effects we must, as far as possible, assign the same causes." Kepler unified planetary motion. Newton unified all motion. The chain from observation to mathematics to physics is complete. But Kepler's life during these discoveries is chaos. 1611. His wife Barbara dies from typhus. 3 of his children die. Prague is unstable, war brewing. He moves to Linz. 1612. He remarries Susanna Reutinger. They have 7 children together. 5 die young. December 1615. News arrives from Leonberg, his hometown. His mother Katharina has been accused of witchcraft. 73,000 people tried for witchcraft across Europe. Nearly 50,000 executed. 25,000 in Germany alone between 1560 and 1700. 75% of the accused are women. Ursula also confided she was pregnant by a man other than her husband. Katharina told Kepler's younger brother. The brother spread it around Leonberg. Ursula's brother, a barber, hears about Kepler's manuscript Somnium the Dream, written 1609, a story about traveling to the moon. One character is a wise woman named Fjellshilde, who communes with demons. The barber tells people Katharina is a witch. The accusations pile up. She magically appeared through closed doors. She paralyzed a schoolmaster with wine. She hit a girl's arm, causing inhuman pain. Kepler's own brother Heinrich claims she rode a calf to death and prepared it as a roast. 49 counts of witchcraft. 2 guards watch her constantly. Kepler abandons his astronomical work. He moves his family south. He writes a 128-page defense, demolishing every accusation with logic and medical explanations. The schoolmaster's paralysis, stroke, the girl's arm pain, natural illness, the closed door appearance. She knocked and was let in. His defense is systematic, ruthless, scientific. The Judicial College at the University of Tübingen rules there is insufficient evidence on either side. Instead of releasing her or ordering torture to extract confession, they order her shown the instruments of torture. Hot irons, pincers, long needles, the rack, the gallows. She is told what will happen if she confesses. She refuses. 14 months in chains. October 16, 21. She's acquitted, freed. But the ordeal is over. The trial cost Kepler over 900 guilders, more than 2 years' salary. Costs inflated by delays, excessive charges for heating, food, guards. Katharina dies 6 months later, April 13th, 1622, age 75. Kepler never tells colleagues why he left his work. The stigma is too great. Wars ravaging the Holy Roman Empire. He leaves behind 3 laws that describe how every object in the solar system moves. His grave is destroyed during the 30 Years' War. No marker remains, but his laws remain. NASA names a space telescope after him. Launched March 6, 2009, the Kepler Space Telescope searches for exoplanets by measuring the dimming of stars when planets pass in front. It finds over 2,600 planets outside our solar system before its mission ends in 2018. The telescope proves planets are more common than stars in our galaxy. Every discovery uses Kepler's laws to calculate orbital periods, distances, masses. 400 years after he published them, we are still using his work to explore the universe. Most scientists, faced with 8 minutes of arc error, would round it off. Publish, move on. Kepler doesn't. He assumes Tycho is right and his model is wrong. He tears up 2,000 years of circular orthodoxy because the data demands it. He spends 8 years on one planet, 70 failed models. He could have stopped at the circle with Equant. It was close enough. But close enough isn't true, and Kepler cares about true. That is the revolution. Not just the ellipse, not just the laws, the method. Follow the data. Trust the measurement. If the model doesn't fit, the model is wrong, not the data. Revise everything if necessary. Find what is actually happening, not what should be happening according to philosophy. Heisenberg accepting uncertainty because electrons don't have definite positions and momentums simultaneously. Quantum field theory accepting particles as excitations in fields because that is what the math and experiments show. Every breakthrough starts with someone refusing to ignore a discrepancy. Kepler set the pattern. He believes the universe is God's creation structured by divine geometry, the Platonic solids, the musical harmonies. He is searching for the mind of God. That is his motivation, not secular curiosity, religious conviction. And yet his method is ruthlessly empirical. Data over dogma, observation over philosophy. He reconciles faith and science not by compromising either, but by insisting both are about discovering truth. Truth cannot contradict truth. If the data says ellipses, then God uses ellipses. Adjust your theology, not the data. Kepler can. Kepler is willing to say God's perfection is not our perfection. The ellipse is perfect because it is true. Truth is the higher perfection. Voltaire popularizes the term, 1814. Robert Small publishes an account of the astronomical discoveries of Kepler, formalizing the set of 3 laws. The terminology becomes standard, but the laws themselves have been teaching physics for generations by then. University courses, navigation, calendar reform, predicting eclipses, calculating comet orbits. Every practical application of astronomy uses Kepler's work. Apollo 11. Humans land on the moon. The trajectory calculations use Kepler's laws. Every orbit, every maneuver, every rendezvous requires knowing how objects move in ellipses around central masses. 2012, Curiosity rover lands on Mars. The entry, descent, landing sequence depends on calculating Mars's position months in advance. Kepler's laws make it possible. 2015, New Horizons flies past Pluto, 9 years in transit. The navigation team uses Kepler's 3rd law to calculate arrival time and orbital mechanics around the Sun. 2020, Perseverance lands on Mars. Same laws, same math, same principles Kepler fought 8 years to discover. Nature is not obligated to be simple or symmetrical or elegant by human standards. Our job is not to impose order, but to discover what order actually exists. Kepler wanted circles. Everyone wanted circles. Circles are beautiful, symmetrical, perfect. But Mars doesn't care. Mars moves in an ellipse. You can ignore that and publish a beautiful wrong theory. Or you can accept it and publish an ugly true theory. Kepler chose true. That choice echoes through every scientific revolution since. Darwin publishes evolution by natural selection, not because it is comforting, because it fits the data. It explains finch beaks and fossil layers and embryonic development. It is true. Wegener proposes continental drift, not because geologists like it, most don't, because the coastlines match and the fossils align and the rock layers connect. It is true. Hubble measures galaxies receding, not because anyone predicted an expanding universe, because the redshifts are real. The universe is expanding. It is true. Kepler adjusts his expectations. That is why 8 minutes of arc matter. They are not just a measurement error. They are a test. Will you ignore them, or will you let them tear apart your worldview? Thinking about the battle it took to discover them. Ellipses feel obvious now. Of course, planets orbit in ellipses. Of course, they move faster when closer to the sun. Of course, there is a mathematical relationship between orbital period and distance. Obvious. Except it wasn't. For 2,000 years, the best minds in the world believed orbits were circular. Aristotle, Ptolemy, Copernicus, Galileo, all wrong. Why? Because circles fit their philosophy, their aesthetics, their intuition about how the heavens should work. Kepler is willing to be wrong about should and discover what is. That willingness is the hinge. He dies at 58, exhausted, with no grave marker. But his 3 laws outlive empires. They outlive the Holy Roman Empire, which collapses in 1806. They outlive the 30 Years' War that erased his tombstone. They outlive the telescopes that replaced naked eye observation. They outlive Newtonian mechanics, which explains them. They outlive even the classical physics that Newton built. Relativity and quantum mechanics revised Newton, but Kepler's laws still work. They are approximations of deeper truths about space-time curvature and gravitational fields, but they are accurate enough for nearly every application. NASA still uses them, space agencies worldwide still use them, 4 centuries of technological change, and Kepler's math still predicts where planets will be. They are built from observation, not from philosophy. Philosophy changes, observation doesn't. Mars is still there, moving in an ellipse, obeying the area rule, following the period-distance relationship. Kepler measured it correctly. He followed the data to the truth. And truth doesn't age. You cannot overwrite it with a better aesthetic. You can refine it, contextualize it, explain it with deeper theory, but you cannot make it false. The ellipse is not negotiable. Kepler found what is actually happening. That is why the laws last. It doesn't matter if abandoning it requires rethinking everything. Truth is not a democracy. It is not subject to vote. It is what it is. Your choice is whether to ignore it or face it. Kepler faced it. That is the difference between him and everyone before him who failed to solve orbits. Not intelligence, not resources, not luck, willingness. Willingness to let reality destroy his assumptions and rebuild from what remained. The mental process he used is not mystical. It is not genius in some unreachable sense. It is discipline, precision, stubbornness, refusal to quit when wrong. Willingness to try 70 models if that is what it takes. Ability to hold a question open for years without forcing a premature answer. Trust in measurement over theory. Acceptance that nature does not owe you simplicity. These are choices. Difficult choices. Uncomfortable choices. But choices. Kepler made them. That is why his name is on a space telescope and why his laws are still taught in every physics classroom on Earth. Not because he was smarter than everyone else, because he was more honest. Honest with data. Honest with himself. Honest enough to admit when he was wrong and start over. 1704. Voltaire names them laws. 1915. Einstein publishes General Relativity, showing gravitation is space-time curvature, not force. Kepler's laws are now understood as approximations of geodesics in curved space-time. But the approximation is so accurate that NASA still uses Kepler's original formulas for mission planning. 2009, Kepler Space Telescope launches. 2018, mission ends. 2,600 exoplanets discovered. Everyone analyzed using Kepler's third law to determine orbital period, distance, and mass. 409 years from Astronomia Nova to the Kepler mission. The math still works. The method still works. Follow the data. Trust the measurement. Revise everything if necessary. Find the truth. That's how you understand orbits. That's how you understand reality. Mars is still there, moving in its ellipse, sweeping out equal areas in equal time, obeying the period-distance relationship Kepler calculated by candlelight in a freezing room in Prague while his world collapsed around him. The planet doesn't care that Kepler is dead, or that his grave was destroyed, or that his mother was accused of witchcraft, or that his children died, or that his first wife died, or that wars obliterated the empire he worked for. Mars just moves, following the laws Kepler discovered by refusing to ignore 8 minutes of arc. 8 minutes? 1/8 of a degree, the width of a grain of sand at arm's length. Small enough to ignore, too important to dismiss. That's the hinge. That's the moment reality became negotiable or non-negotiable. Kepler chose non-negotiable. We are still living in the universe that choice revealed.